If you remember, in the past we had already released a DAB option. We call it now the basic DAB option. And this option allows you to do mainly three things. One, to tune the DAB channel, demodulate it. We show the power level, carrier to noise, MER, and channel BR for that channel, for that DAB channel, and then we could extract some metadata and present it to you in the TV mode. But now with this new advanced option, we can do several things that are quite interesting for analysis of the DAB signal. First of all, I'll show you some additional measurements that we can show in the measurements mode. Let's go to measurements now that we are already tuning this DAB signal and we are locked to it. You can see ETI locked, ETI locked. We move to the measurements mode, and here, besides the power level, besides the MER, carrier to noise, and channel BR that we were already offering before, this channel BR is a channel BR calculated over the whole ETI. Now we provide you with channel BR calculated only on the MSC. The MSC is the main service channel. This is the part of the ETI where the digital radio services are stored. We calculate as well the channel BR over the FIC. This is the fast information channel. Is the part of the TI that carries the metadata that allows the receiver to extract and retrieve all the different digital radio services. And finally, we provide you with as well the FIB ratio. This is the fast information block ratio. If you don't know, I'll tell you this is extremely important. This is the percentage of correct data that is coming from the CRC, the checksum, that is performed over the FIC. Meaning that what you want here is a 100% of data correct. If it's less than 100%, what it means is that you have some errors in the FIC, in the metadata that the receiver should use to extract the digital radio services. So it's extremely important that this is correct. After that, what you should check is the FIC channel BR. And after that, the MSC and the channel BR for the whole ensemble. Okay, this is just one part of it. Then we have some additional advanced measurement tools for analysis of DAB signals. And we will find them in tools. Again, by pressing F3, we go to tools. And here we find several things. First, remember that DAB plus signals are modulated in DQPSK. And now with the constellation tool, you can check the quality of the received symbols after demodulation. So indeed, this is DQPSK. As well, DAB Plus is using OFDM as a transmission scheme, meaning that the available bandwidth, the 1.6 megahertz that occupies a DAB channel, is divided into a number of narrow band subcarriers, and you can now check the MER of each one of these subcarriers. So if you go to the tool MER by carrier, which is what you're seeing now, from side to side on the screen, this is the total bandwidth of our DAB channel, 1.6 megahertz, and on the horizontal axis what you see is number of carriers. This is the number of carriers that are used for OFDM transmission. And in the vertical axis, what you see is not power level, is MER value. As you can see, this signal is quite bad quality, good enough to be able to log, but not that good. So the MER value of the different carriers is really, really going up and down. What else? We have another analysis tool, the echo analyzer. It's important as well to know that DAB and DAB plus signals can be transmitted under SFN networks, meaning that it would be very handy if you could have in reception a meter that features an echo analyzer, because then it would allow you to check if the main signal that you're receiving from the main transmitter is being interfered by echoes that are coming from distant transmitters. And this we can see here in the echo analyzer. How you use the echo analyzer is the same way that you would use it for analyzing the echoes in a DVB-T or DVB-T2 signal case. You can zoom in. You can see in blue the main signal that the demodulator chose as the preference signals for demodulation. And in white you can see the echoes. Then for each one of these signals you can see power level, delay and distance. Everything in the red area is the part of the time that falls outside the guard interval, and everything in between is what falls within the guard interval. Okay, now more tools for analysis of DAB. You can record the ETI, the whole ensemble. You can record it in the internal storage, and after that you can transfer it to an external pen drive for further analysis with any other software. You can record as well the in-phase and quadrature components from the receiving symbols, the symbols that are received after the modulation. This is saved in a WAV file, which can be again transferred to an external pen drive so that it can be opened up with third-party software like, for example, MATLAB. And finally, the last tool I want to show you is this DAB TII information. The TII is information that is sent during the transmission of null packets. Every 2 null packets, you transmit this information, and you don't use all of the OFDM carriers. You just use some of them, which are these peaks that you can see every now and then. These are the ones that are used for transmitting this TII information. And what is the TII information? It's these 2 identifiers here, mainly. The main one is an identifier that defines the country and region where the signal is coming from, where it's being transmitted from. And the sub is identifies the transmitter from which we are receiving the signal, the DAB signal. In green, what you can see is the PRS symbols. These are the symbols that are used by the receiver to be able to sync to the DAB signal. So this would be the whole set of new features that you can find in the new advanced DAB Plus option. I think you will find them exciting and most of it quite helpful.